everyone, I'm Siddhartha. I'm a second year BTech IT student from NSCC, Kolkata. Now, welcome to our channel CodeChef. Today, we would be discussing the problem Primality Test, and the problem code of this problem is PRB01, and the difficulty level of this problem is easy and the prerequisite are none. Now, let us look at the problem statement. So, we are given a number n and we need to tell if it is a prime or not prime. Okay. So, to solve this problem, let us first understand which number is called prime and which is not called a prime. Okay. So, prime number are numbers which are divisible by only 1 and itself. Okay. Let me write 1 and itself. Okay. And it is not divisible by any other numbers. Okay. Such that suppose the number is 29. So we know that 29 is a prime number because 29 is only divisible by 29 and 1. And there is no other number which can completely divide 29. So if we want to confirm if a number is prime or not, so we can check if there exists any number which can completely divide it except 1 and the number itself. So suppose the number given is 5, then we can check from 2, 3, 4 itself because 1 and 5 would be not included, okay, in the testing. So 2, 3 and 4 would be included. That's how we can check it, okay. Now let us look at the input and the output. So we are given t number of test cases and in each test case we are given a number n and we need to check if it is a prime or not. If it is a prime, then we need to print yes, else we need to print no. Now let us look at the constraint so that we have an idea till which the complexity of our program can we afford. It is a thumb rule that in 1 second the compiler can perform 10 to the power 8 operations. Okay. So now it is given that n's upper bound can be till 10 to the power 5. So 10 to the power 5 multiplied with the number of test cases. So 10 to the power 1 itself, that is 10 to the power 6 because the powers would get added as the bases are same. 10 to the power 6. So we can afford a big O of n solution because big O of n solution would lead to 10 to the power 6 operation which is less than 10 to the power 8 itself. Okay, so to solve this problem, at first we need to handle each test cases. To handle each test case, we would be using a simple while loop. Okay, moving ahead, okay, to test each number, we can afford a big O of n solution, okay, and it would pass. So what we can do is, suppose the number is 10, then we can check from 2 to 9 itself. We would check from 2 to 9, and if there exists any number which can completely divide the number n, then the answer would be no, else the answer would be yes itself. So we can check from number 2 to the number n minus 1 by simply using a for loop. Now the problem comes how to check if it is divisible or not. We can simply use a modulo operator which would tell the remainder when it is divided. Okay. So if the remainder is 0, that means the number is divisible. Else if the remainder is not 0, then the number is not divisible. Okay. Now let us implement this. The boilerplate is already written so that we can save time. So we would be taking the input of test case and then cin test case and then while loop, while tc minus minus is greater than 0. Then we would be provided with a number n. So int n and then cin n. Okay. So now if the number is 1, then we would be printing no because 1 is universally regarded as not a prime number. So if n is equals to 1, we see out no with an and then okay, then continue. So if the number is 1, then we would be printing no with an end line and then continue. This means that we would skip the rest of the iteration and move forward to the next test case. Okay. Then we would need to store our answer if we got any divisor or not. So at first we would be initializing a boolean with true, and if at any point we can make it false, then it is not a prime number, else it is a prime number. So bool prime is equals to true itself, then we would be using a for loop. Int I is equals to 2, I is less than n, and I plus plus. Okay, this would check the number from 2 to n minus 1. Okay, so if n modulo I equals to 0, then means that we would make the prime boolean false. Prime is equals to false. We can implement a break statement so that we don't check further. You can skip this also. Okay, so I would be implementing a break because it would make the program more efficient. Okay, then if the prime remains true, then we would be printing yes with an end line. Okay, else if the prime has become false, we would be printing no. Let's check on the sample test cases. And yes, it has passed on the sample test cases. Now let us submit our code and see if we get an AC. Let us paste our code and click on submit, and now let us wait for the verdict itself. And yes, we got an AC. If you are interested in competitive programming and want to learn and master data structures and algorithms, this is a one-stop destination for you. Every week, we post CodeChef problem explanation, live problem solving sessions, and frequently asked interview problems. Consider subscribing this channel if you haven't yet already.